divisible by 1 to 10. Every number in general is divisible by 1 and the result is the number itself. Say for example, when 1 divides 5, the result will be 5. When 1 divides 3, the result will be 3. When 1 divides 8, the result will be 8. When 1 divides some 100, the result will be 100. Like this, every number in general is divisible by 1. To discuss about the divisibility of a number by the numbers 2 to 10, it is better to remember the following tables, which will help us to have a better understanding of the divisibility of a number by the numbers 2 to 10. Before that, let's separate the numbers 2 to 10 into some groups which are having more or less similar divisibility rule. Since the divisibility rule of 2, 5 and 10 depends on the ones place or the last digit of the number, we put these numbers into one group. Since 3 and 9 are having same kind of divisibility rule, put 3 and 9 into another group. Since 4 and 8 are having same kind of divisibility rule, put 4 and 8 into another group. And at last, consider the rest of the numbers 6 and 7 into one group, as 6 has the divisibility rule of 2 and 3 and 7 has completely different divisibility rule. Now let's have a look on the divisibility rule tables. Now look at the first table. This row denotes the last digit of the number and this column denotes the divisors. Consider the first row. A number is divisible by 2 whenever the number having its last digits as 0 or an even number. Look at the second row. A number is divisible by 5 whenever the number having its last digits as 0 or 5. Now look at the third row. A number is divisible by 10 whenever the number having its last digit 0. Now see the first column. If a number whose last digit is 0, then it is divisible by 2, 5 and 10 also. Now look at the second column. A number whose last digit is an even number, then it is divisible by 2. Now look at the third column. A number whose last digit is 5, then it is divisible by 5. Shortly speaking, divisible by 2 last digit is 0 or an even number. Divisible by 5, the last digit is 0 or 5. Divisible by 10, the last digit is 0 alone. See this table 2. This table describes the divisibility rule of the numbers 3, 9, 4 and 8. This row is the digits of the numbers and this column is the divisors. See the first row. If the sum of all the digits of the number is divisible by 3, then the number is divisible by 3. See the second row. If the sum of all the digits of the number is divisible by 9, then it is divisible by 9. See the third row. If the last two digits of the number is divisible by 4, then it is divisible by 4. See the fourth row. If the last three digits of the number is divisible by 8, then it is divisible by 8. Now see the first column. If the last two digits of the number is divisible by 4, then it is divisible by 4. Now look at the second column. If the last three digits of the number is divisible by 8, then it is divisible by 8. See the last column. If the sum of all the digits of a number is divisible by 3, then it is divisible by 3. If the sum of all the digits of the number is divisible by 9, then it is divisible by 9. Therefore, divisible rule of 3 is sum of all the digits is divisible by 3. Divisible by 9 is sum of all the digits is divisible by 9. Divisible by 4 is last two digits is divisible by 4. Divisibility of 8 is last 3 digits is divisible by 8. Now let's see the divisibility rule of 6. If a number is divisible by both 2 and 3, then it is divisible by 6. The divisibility rule of 7 is completely different. We will discuss it later. These tables are designed based on the divisibility rule of the numbers 2 to 10. The cells which are not having tick mark, these cells, may or may not be possible, but it doesn't matter as we have the divisibility rule for all the numbers from 2 to 10. Now let me show you some examples. Consider the number 4,58,67,580. 4,58,67,580. Such a big number is this. And another one example is 45,86,778. And another one number 64,92,465. Now let's see the divisibility of these numbers. So look at the first number. Look at the first example. Since the last digit of the first number is 0, then according to the first table, the first number is divisible by 2, 5 and 10. Now look at the second example. Since the last digit of the number is 8 and which is even, then again according to the first table, the second number is divisible by 2 but not divisible by 5 and 10. Now consider the third example. Since the last digit of the third number is 5, then again according to the first table, the third number is divisible by 5 alone but not divisible by 2 and 10. Now we have verified that the divisibility of 2, 5 and 10. Now let's see the divisibility of 3 and 9. Since the divisibility of 3 is the sum of all the digits is divisible by 3 and the divisibility of 9 is the sum of all the digits is divisible by 9. Find the sum of the digits of the first number. 4 plus 5 plus 8 plus 6 plus 7 plus 5 plus 8 plus 0. Then the sum is 4, 9, 17, 23, 30, 35, 43. The sum of the digits of the first number is 43. So find whether this 43 is divisible by 3 and 9. If you feel difficult, then again do the same process. 4 plus 3 equal to 7. Since this 7 is not divisible by 3 and 9, the first number is not divisible by 3 and 9. Now find the sum of the digits of the second number. 4 plus 5 plus 8 plus 6 plus 7 plus 7 plus 8. The sum is 4, 9, 17, 23, 30, 37 and 45. 45. Again 4 plus 5 is 9. This 9 is divisible by both 3 and 9. So therefore the second number is divisible by 3 and 9. Now find the sum of the digits of the third number. 6 plus 4 plus 9 plus 2 plus 4 plus 6 plus 5. 6, 10, 19, 21, 25, 31, 36. 36. Again the sum is 3 plus 6, it is 9. Again this 9 is divisible by both 3 and 9. The third number is divisible by 3 and 9. Now we have verified the divisibility of 2, 5, 10, 3 and 9. Now let's see the divisibility rule of 4. The divisibility rule of 4 is if the last two digits of a number is divisible by 4, then the whole number is divisible by 4. Now look at the first example. The last two digits of the first example is 80. Now check whether this 80 is divisible by 4 or not. Since 80 is divisible by 4, the result is 20. 20 times 4 is 80. 4 times 20 is 80. 80 is divisible by 4. So therefore, the first number is divisible by 4. Now look at the last two digits of the second number. The last two digits of the second number is 78. Now check whether this 78 is divisible by 4 or not. 4. 1 4 is 4. The remaining is 3. And this 8 is here. 9 4s are 36. The remainder is 2. When 4 divides 78, leaves the remainder 2. So therefore, this 78 is not divisible by 4. So therefore, the second number is not divisible by 4. Now look at the third example. The last two digits of the third example is 65. Now check whether this 65 is divisible by 4 or not. 1 4 is 4. The remainder is 2. And this 5 is here 25. 6 4s are 24. The remainder is 1. When 4 divides 65, leaves the remainder 1. So therefore this 65 is not divisible by 4. So therefore the third number is not divisible by 4. Now let's see the divisibility rule of 8. If the last three digits of a number is divisible by 8, then the whole number is divisible by 8. Now look at the first example. The last three digits of the first example or first number is 580. Now check whether this 580 is divisible by 8 or not. 7 8s are 56. The remainder is 2. And this 0 is here 20. 2 8s are 16. Leaves the remainder 4. When 8 divides 580, leaves the remainder 4. Therefore this 580 is not divisible by 8. Therefore, the first number is not divisible by 8. Now look at the second number. The last three digits of the second number is 778. Now check whether this 778 is divisible by 8 or not. 9 8s are 72. The remainder is 5. And this 8 is here 58. 7 8s are 56. The remainder is 2. When 8 divides 778, leaves the remainder 2. So therefore we can say that this 778 is not divisible by 8. So therefore the second example is not divisible by 8. Now look at the third example. The last three digits of the third example is 465. Now check whether this 465 is divisible by 8 or not. 5 8s are 40. The remainder is 6. Now this 5 is here 65. 8 8s are 64. The remainder is 1. When 8 divides this 465, leaves the remainder 1. So therefore we can say that this 465 is not divisible by 8. So therefore the third example, the third number is not divisible by 8. Now let's see the divisibility rule of 6. If a number is divisible by both 2 and 3, then the number is divisible by 6 also. Now look at the first example. The first number is divisible by 2 but not divisible by 3. So therefore the first number is not divisible by 6. Now look at the second example. The second number is divisible by both 2 and 3. So therefore the second number is divisible by 6 also. Now look at the third example. The third number is divisible by 3 but not divisible by 2. So therefore the third number is not divisible by 6. Now we have verified the divisibility rule of the numbers by 1 to 10 except 7. Now let's see the divisibility of 7. Before getting to the divisibility rule of 7, firstly denote the given number as RL. This L is the last digit of the given number and this R is the remaining digits of the number. For instance, suppose we want to check whether the number 256 is divisible by 7 or not. Then denote this number as RL. The digit 6 is L and the remaining digits 2 and 5 together denoted by R. Suppose we want to check whether the number 647 is divisible by 7 or not. Then 7 is L and the remaining digits 64 is R. Now the divisibility rule of 7 is R minus 2L. If the difference is 0 or divisible by 7, then the given number is divisible by 7. Now let's get into our examples. Now look at the first number. Since the last digit is 0, 2L is 0. This 0 is 2L and the remaining digits are. Subtract this 2L from R. The resulting value will be 8, 5, 7, 6, 8, 5, 4. Here the last digit is 8 and 2 times 8 is 16. Subtract this 16 from the remaining digits. This 16 is 2L, the remaining digits are. Subtract this 2L from R. The resulting value will be this 9, 5, 6, 8, 5, 4. Now the last digit is 9 and 2L is 18. 2L is 18. So these are the remaining digits. Now subtract this 2L from R. The resulting value will be 7, 4, 8, 5, 4. Now the last digit is 7. L is 7. 2L is 14. So 2L is 14 and R is the remaining digits. The remaining digits are, subtract this 2L from R. The resulting value will be 0, 7, 5, 4. Here the last digit is 0. Therefore 2L is 0. Again we have the same number. Now the last digit is 7 and 2L is 14. Subtract this 14 from the remaining numbers. The resulting value will be 1, 3. Since this value is not divisible by 7, the first number is not divisible by 7. The first number is not divisible by 7. Now look at the second example. The last digit is 8. Therefore 2L is 16. Subtract this 2L, that is 16, from the remaining digits. The resulting value will be 1, 6, 6, 8, 5, 4. Here the last digit is 1. Then 2L is 2. Subtract this 2 from the remaining digits. The resulting value will be 4, 6, 8, 5, 4. Now the last digit is 4 and 2L is 8. Subtract this 8 from the remaining digits. The resulting value will be 8, 7, 5, 4. Here the last digit is 8. 2 times 8 is 16. Now subtract this 16 from the remaining digits. The resulting value will be 1, 4, 4. Here the last digit is 1. 2 times 1 is 2. Subtract this 2 from the remaining digits. The resulting value will be 42. Since this 42 is divisible by 7, the second number is divisible by 7. The second number is divisible by 7. Now consider the last example. The last digit is 5. 2 times 5 is 10. Subtract this 10 from the remaining digits. The resulting value will be 6, 3, 2, 9, 4, 6. Now the last digit is 6. 2 times 6 is 12. The difference is 1, 1, 9, 4, 6. Now the last digit is 1. 2 times 1 is 2. The difference is 9, 8, 4, 6. Now the last digit is 9. 2 times 9 is 18. Now the difference is 0, 3, 6. Now the last digit is 0. 2 times 0 is 0. The difference will be 63 again. Now the last digit is 3. 2 times 3 is 6. The resulting value will be 0. Since the resulting value at last is 0, the third number is divisible by 7. The last example is divisible by 7. No need to proceed this much. Whenever you can find the divisibility, then there you can stop the process. At any stage you can find whether the resulting value will be divisible by 7 or not. If you feel difficult to find the divisibility of the number by 7, then again and again do the same process until get the smaller number. Thanks for watching this video.